Hey folks, this is the matrix vector test review. I'm just going to go through this really quick. We did this in class, but it should be pretty straightforward. This is 2a plus b. Remember a right here and b are matrices. So it's 2 times matrix A, and then plus matrix B is 4, negative 1, 2, and 0. Alright, so if I distribute this 2 in here, I got 2 times 2, this will give me the matrix 4. 2 times negative 4, which is negative 8. 2 times 1, which is 2. 2 times 3, which is 6. And then we're going to add this matrix here. 4, negative 1, 2, 0. 4 plus 4. Top left corner, added the top left corner. This is going to be 8. Negative 8 plus negative 1 is negative 9. 2 plus 2 is 4. And 6 plus 0 is 6. So that is your answer for number 1. Let's go on to D. Change the color up to, say, blue. This is 3 times the vector D, which is 3, 1, times the vector C, which is 4, 3. And one thing I would like for you to take notice of, something that's rather important, is that vector D is a 1 by 2 matrix, and vector C is a 2 by 3. I'm sorry, a 2 by 1 matrix. This and this, the number of columns in the first matrix must match the number of rows in the second. If these numbers don't match, you can't multiply them. The answer would be undefined. So if these match, which they do, I can multiply these matrices. Another thing that you should take notice of is that this number here, this first and last number, are the dimensions of your answer, of your product when you multiply these. So I'm going to have a 1 by 1 answer, which is just a number. So I'm going to leave the 3 out for these purposes, and I'm going to say, okay, I'm going to have a matrix here. I'm going to multiply this row by this column. So how I do that is it's like taking this row and dropping it through this column and say 3 times 4. This will be the first thing, first times first. And then we're going to say plus 1 times 3. And what that's going to give me is 3 times, this is going to be 12 and 3, so 15. And that will give me the matrix 45. This is the final answer, which is a 1 by 1 matrix. Okay, so that's the answer for D. All right, let's do number 3 here. We're going to multiply matrix A by E. Okay, so let's do matrix A. Matrix A right here is 2, negative 4, 1, and 3. We're going to multiply this by matrix E, which is this 2 by 3 right here, kind of longer. Alright, so let's go through that exercise again. When you're multiplying matrices, it's not a bad idea to write this, but what I really have here is a 2 by 2, and this is a 2 by 3. The last number matches the first number here, so that's good. That means we can multiply them. Our answer will be a 2 by 3 matrix for the answer. So what I really have here is I'm going to take this row and multiply it by this column here, first column. So it's 2 times negative 3. And I'm going to add negative 4 times 1. And then I'm going to say the first row times the second column, which is 2 times 2, plus negative 4 times negative 1. And then I have this row times this third column, which is 2 times 0, and negative 4 times negative 2. Basis. So we got this 1, we're going to say this row times this first column, so that's 1 times -3, plus 3 times 1. Now the first row times the second column, so it's going to be 1 times 2, plus 3 times -1. And then the last row here by the last column, so it's going to be 1 times 0, plus 3 times -2. So when I resolve this, I'm going to change my pen here to do quick calculations. That's going to be -6, this times this times this is -4, this times this is 4, this times this is 4, this times this is 0, this times this is 8, this is 0, -6, 2, -3, -3, and 3. So, -6 minus 4 is -10, 4 plus 4 is 8, 0 plus 8 is 8, -3 plus 3 is 0, -2 minus 3 is -1, 0 minus 6 is -6, and lo and behold, that's your final answer. And as I promised, it was a 2 by 3 matrix, and so it is 2 by 3 for the answer. So that's your answer for number 3. Alrighty, let's do number 4. Number 4 is B minus 2A. Let's take a quick look again. B is 4, -1, 2, 0. 4, -1, 2, 0. Minus 2 times A, which is 2, -4, 1, and 3. Okie doke, no problem. So, I'm going to basically just keep the first matrix for the time being. And I'm going to go ahead and distribute this 2, or this -2, into this. So if I distribute a +2, I'll be subtracting still. If I distribute the -2, then I start adding. So really either way will work. I'm just going to distribute the +2, so I'm going to keep the negative sign. So 2 times 2 is 4, 2 times -4 is -8, 2 times 1 is 2, and 2 times 3 is 6. And remember, I still have a negative because I distributed +2 instead of the -2. If I distributed the -2, this will become a positive sign, so be careful. So 4 minus 4 is 0. -1 minus -8 is -1 plus 8, which is 7. 2 minus 2, which is 0. And 0 minus 6, which is -6. And that is your final answer for number 4. B plus D. We can only add matrices if they have identical dimensions. B is a 2 by 2 matrix right here. So I can only add it to another 2 by 2 matrix. D, right here, is a 1 by 2. And since these dimensions are different, I can't add these at all. It's not possible. So this answer is undefined. Okay, the dimensions are not the same, which is required for adding and subtracting matrices. So that is that answer. And we'll jump over to the next question, and we'll do some Cramer's rule problems through here. We'll do the Gauss-Jordan elimination on number 9. And that'll put us about halfway through the test review, and we're done with that. So let's see what happens. All right, Gauss-Jordan elimination. We've done this before several times. D is what I have. I'm going to create a coefficient matrix. So we have the x's. So I'm going to have what is called my x column and my y column right here. And I'm looking at here, and I have x's lined up and my y's lined up, and that's a 1x right there. So let's change my pen color to blue here and say, okay, 1 is my first one, -4 is the next number for x, -5 is the first number for y, and -2 is the second number for y. So to find this determinant, it's pretty easy. It's this corner times this corner, which is 1 times -2. Then I'll subtract this times this. So -4 times -5. What this gives me is -2 minus 20, which is -22. So that's something to look at. And that's D, our value for D. Now I have to do this twice more. And I'll make another one, a determinant, called dx. And what I'm going to do for this is I'm going to replace this x column that I have Okay, I'm going to replace this x column with these numbers on the end, -5 and 20. And I keep the y values the same, these y coefficients rather. And then we'll do this again. This times this, which is -5 times -2, minus this times this, which is 20 times -5. This will give me positive 10 minus a negative 100, which is the same thing as adding 100, so this is 110. Lastly, we'll do dy. So dy, this time we're going to place the y column with these two numbers on the end. So we have 1, -4, and the last two numbers will be -5 and 20. And then we'll do the last process. This times this, 1 times 20, minus this times this, which is -4 times -5. So that's going to be 20 minus 20, which it should in turn be 0. So the whole premise of this exercise is find the coordinate xy where these two lines intersect. Okay, so that's pretty straightforward. I'm going to say x will be dx over d, and y will be dy over d. And dx I determined is 110, and d right here is -22. So that's going to equal -55 over 11, so this is -5. dy will be 0 over -22, because dy is right here, 0. So this will be 0. So this is my x value and my y value, so my final answer, the coordinate where these two lines intersect, is the coordinate -5, 0. And that's your answer for number 6. Kramer's rule. All right, let's jump down to number 7. And we'll do the same process here. So see if I can get some separation here. We'll try to do number 7. Try not to use so much space, I guess. Let's do this in a different color. Let's do it in red. All right, so we're going to do D again. Find that coefficient determinant matrix. Be careful. All right, so we got 3 and -5 and -4 and 2. Y's line up with Y's, X's and X's. So this is 3 times 2, which is 6, minus -5 times -4, which is 20. So this is -14. I'm going to go ahead and find dx. We'll replace the x column with these numbers here, 1 and 3. I got -4 and 2. This is 1 times 2, which is 2, minus 3 times -4, which is -12. So it's basically 14, because -2 minus -12 is -2, is it's 2 plus 12 now, so 14. dy, the final one we'll do. We'll replace the y column with 1 and 3. X column is the same, 3, -5, so we got 1 and 3. That's a 3. I'm going to say 3 times 3 is 9, minus -5 times -1, which is -5. So 9 plus -5 is again 14. So we can get our answers now. I'm going to say, of course, that x is equal to dx over d. dx is 14, d is -14, so 14 over -14, which is -1. And y will be dy over d, which is 14 over -14 as well, which is also -1. So the ordered pair for the answer is -1, comma, -1. And that's your solution for number 7. Okie doke, let's do number 8. Same way we've done the last two. So we'll do D, coefficient matrix 2, 4, 2, and -1. So 2 times -1, which is -2, minus 4 times 2, which is 8. So -10. dx, we'll replace the x column with 0 and -20. Keep the y column as 2 and -1. 0 times -1 is 0, minus -2 times 2, which is -40. So this would be positive 40. And then dy, replace the y column with these, so That'd be 2, 4, 0, negative 20. 2 times negative 20 is negative 40. Minus 4 times 0, which is 0, so negative 40. So we can get the solutions for these. So we're going to say x is equal to dx over d, which in this case is 40 over negative 10, so negative 4. Y will be dy over d, which is negative 40 over negative 10, which is 4. So your answer is, as an ordered pair, is negative 4, comma 4. And that's your solution to this. All right, here we are, number 9, Gauss-Jordan elimination. Everybody's favorite, I know. So this is kind of different. What I'm going to do for this question is I'm going to create an augmented matrix. And I'm going to what I'm trying to find is the system. So I'm going to find, again, same thing I've already been doing, finding the coordinate where the two lines cross or they intersect. But we're going to put 7 on my x column and negative 4. And then for the y, negative 1, negative 2. We'll put a little vertical line here and put negative 1, negative 2. And this will be part of my augmented matrix. Now the goal for me is to make this left side right here the same thing as 1, 0, 0, 1. I want this matrix, which is the identity matrix. So I want to get these 4 numbers to look exactly like these 4 numbers. And then what happens to these 2 numbers on the end is they become the answer to the system. So the only thing I can do to these rows in this matrix is to multiply these rows by numbers called scalars, or I can add the rows together. And that's the only 2 things I can do. So if I want this to be a 0, this top right, I have to make this a 0. So I look at the other row and I say, okay, what do I add to negative 2 to make 0? Well, that would be a positive 2. So I'm going to have to multiply the top row by negative 2 to get a positive 2 there. So let me show you what I'm talking about. We're going to multiply the top row by negative 2, so negative 2 times row 1, and we're going to fill in this row. All right, so let's figure out what happens. So negative 2 times 7 is negative 14. Negative 2 times negative 1 is 2. Negative 2 times negative 1 is also 2. And then we'll keep the bottom row exactly the same without altering it. What I'm now going to do is I'm going to add row 1 and row 2 together and replace the first row. So when I do that, I know that negative 14 plus negative 4 is negative 18. 2 plus negative 2 is 0, and 2 plus negative 2 is also 0. I will keep the bottom row exactly the same. And what I noticed when I do this is that I wanted this negative 1 to be a 0, and lo and behold, it has become a 0. That's what I have. My next step, since I have a 0 on the top right now, is to get a 0 on the bottom left. So I need to get a 0 where this negative 4 is. Now this can be achieved a couple of different ways, but what I'm going to notice is that if I multiply 18 by 2, I'll get 36, and if I multiply 4 by 9, I'll get 36. So I can just do a couple other row operations here. And what I'm going to do is multiply the top row by 2. So negative 18 times 2 is negative 36. Negative 18, sorry, 0 times 2 is 0, and 0 times 2 again is 0. I'm going to multiply the bottom row by negative 9. So negative 9 times negative 4 is positive 36. Negative 9 times negative 2 is 18. And then I'll get 18 again, because negative 2 times negative 9 is 18. And now, what I'll do is I will add row 1 and row 2 together. And I'll come back over here. I'll keep the top row exactly the same. So negative 36, 0, 0. This row is now the 2 rows added together. So negative 36 plus 36 is 0. 0 plus 18 is 18. 0 plus 18 is 18. So I wanted a 0 on the bottom left and the top right, just like this one is, and it is. So now all I have to do is to get this top left to be a 1, so I just divide negative 36 by itself. Okay, so I'm basically telling you row 1 divided by negative 36. That's what I'm telling you, row 1 divided by that. Okay, And then we'll do row 2, we'll divide by 18. That'll give me the 1 on the bottom right that I want. So it's like basically 1 over 18 times R2. Same thing, right? So let's see what happens. All right, so what is negative 36 divided by itself? 1. What is 0 divided by negative 36? 0. What is 0 divided by negative 36? Also 0. What is 0 divided by 18? 0. What is 18 divided by 18? 1. And 18 divided by 18, 1. This is the matrix that I wanted. It's this identity matrix, and I have it right here. This right here, left over, and the right side, as I told you, should be the answer. This will be your x value. This will be your y value. So the ordered pair where the two lines intersect is 0, 1. That's your solution. Right here, 0 and 1. And that's how you use Gauss-Jordan elimination. Okay. Next question, number 10. Everyone's favorite, the vectors. All right, so I need a vector from P to Q and a vector from R to S. So let's figure out what those are first. So PQ, a vector from P to Q, this can be found by taking the coordinate vector of the end, which is Q, and subtracting the coordinate vector of the beginning, which is P. So because I end this vector at Q, I'll put that first and subtract where I began, which is the coordinate vector P. So the coordinate vectors are given by these coordinates. So Q is 6, 10. And we'll subtract P, which is negative 7, negative 6. And this will give me 6 plus 7, which is 13, and 10 plus 6, which is 16. I will now find the vector RS by taking the coordinate of S and subtracting the coordinate vector of R. So S I can see is negative 3, 7. I'll subtract R, which is negative 3, negative 9. This will give me 0 and 16 again. Okay, so finally we can get this answer. We will just take these two together, add them. So PQ I told you is 13, 16. We're going to add RS, which is 0, 16. 13 plus 0 is 13. And 16 plus 16 is 32. So this is your answer when you add these two together. Okay, that's number 10. All right, number 11. Let's change it up. Let's get blue. We're going to find negative 3AB plus 2CD. Well, let's figure out what AB is first, and then we'll figure out CD, and then we could probably make some sense of this. So AB, the vector from A to B, we'll take the B vector and subtract the A vector, the position vector first, coordinate vector. So we're going to say, okay, so that's going to be 3, negative 1, minus 10, 0. 3 minus 10 is negative 7. Negative 1 minus 0 is negative 1. So that's AB. CD will be given by the coordinate vector for D minus the coordinate vector for C. So D will be negative 2, 9, and we'll subtract C, which is negative 5 and 7. And I'll get 2 minus negative 5, which is 2, negative 2 plus 5, which is 3, and then 9 minus 7, which will be 2. So lo and behold, now I can solve the question. I got negative 3 times AB, so that's basically saying negative 3 times negative 7, negative 1. Oops, there's my pen here. Let's get this pen back, if I can. Yeah, good. And then plus 2 times CD, which is 3, 2. So this will give me, I'll distribute into these, so this will give me 21 and 3 plus 6 and 4. So 21 plus 6 is 27, 3 plus 4 is 7, and this will be your answer. Okay, that's what this is right here. All right, so that's your answer for number 11. So let's go ahead and number 12. Number 12, we'll do this in red. We have to do the vector tx and yz. You have to figure out what they are. So tx, of course, will be x, position vector x minus position vector t, which is 3, 10 minus negative 3, 8. 3 minus negative 3 is 6, and 10 minus 8 is 2. We'll do yz now, which is z minus y, which is negative 8, negative 10, minus negative 4, negative 7. So negative 8 minus negative 4 is negative 8 plus 4, so which is negative 4. And negative 10 minus a negative 7 is negative 10 plus 7, which is negative 3, by the looks of things. So now I have to do this 4 times tx and then plus 2 times yz. So I'll do 4 times tx, which is 2, plus 2 times yz, which is negative 4, negative 3. This will also give me, distribute this 4 into here, we'll get 24 and 8 plus negative 8, negative 6. So 24 minus 8 is 16, and 8 minus 6 is 2. So your final answer will be 16 and 2. Okay, and we're moving right along. Okay, so number 13, given the coordinates a and b, find a unit vector in the direction of AB. That's not a problem. So I'm going to say, okay, I need to find the vector AB first, so before I do anything else. So I say the vector AB will be given by the endpoint B minus the position vector A. So it's like saying negative 6, 10 minus 4, 0. This will give me negative 10, and 10 minus 0 is 10. So this is actually the vector AB. And I want you to imagine this if this were graphed in reality here. If I had a graph, and this were negative 10, and this were positive 10, then the vector AB would look something like this. It would go from here upward to here-ish. And that would be the vector AB. What I'm after, the question, is a unit vector in the direction of AB. So I want another vector that's only going so far that has a magnitude of 1, a distance of 1, going the same direction as AB, but AB is actually going further than 1. How far is AB actually going? How long is this red vector? Well, that's actually pretty easy to find, and I have to find it to solve this question. So let me show you how. We're going to find the length of AB from here to here, okay? So we're going to basically say, okay, the length of AB is its magnitude. We denote it with these little absolute value symbol here. And what we're going to do is we're going to take the square root of negative 10 squared, and then the other number, 10, plus that one squared. So what this really is giving me is a square root of 200, which I know is the same thing as the square root of 2 times 100, right? So if I take the square root of 100, I actually know that's the same thing as 10, so I can take the 10 out of the square root. That's gone now, and what's left inside is root 2. So that's the magnitude of AB, 10 root 2. That's how long this red graph is, this red vector, sorry. And I want another vector that's going the same direction, except its magnitude will be 1 instead of 10 root 2. So what I'm going to do is create a unit vector, and this is how I'm going to go about doing it. A unit vector will be denoted with a hat most often. So that means this little hat symbol means it's a unit vector, its magnitude is 1, and it's going to go the same direction as AB. So to find this unit vector, I'll take the coordinates of AB, the vector components rather, so negative 10 and positive 10, but I'll divide them both by the magnitude of AB, which is this, which is 10 root 2. So I'll divide both of these by 10 root 2. And this will give me the unit vector, but I can sort of simplify this a bit. These 10s will cross out, these 10s will cross out. So negative 1 over root 2 and 1 over root 2. And then I'm going to multiply top and bottom by root 2 to get rid of the radical on the bottom. So then I'll get negative root 2 over 2 and positive root 2 over 2. And this will be my unit vector AB. It's actually in the same direction as AB itself. So that's the answer for this. This is what I'm really looking for. Alrighty, and then I think we're on the last page finally. So that's pretty nice. Okay. And here we're going to find the component form of the resultant vectors for 10, 11, 12. And wait, did I already do this one? I believe I've already done this one. Here we go. So right here on the last page, it says, for the following, draw a vector diagram to find the resultant of each pair of vectors using the triangle method. Then state the magnitude and direction angle of the resultant. So this, when I'm saying resultant, we're going to add these vectors together. And this vector here and this vector here. All right, we're going to add them together. So we're going to have m plus n. So let's go ahead and do that when I think about it. So let's just say negative 7 and 1 added to 12 and negative 16. When I do that, negative 7 plus 12 is 5, and 1 plus negative 16 is negative 15. So what I want to do is draw a graph over here. Make it kind of sizable. About thereabouts, okay? And we're just going to do a sketch here. This one's kind of got big numbers with it, so it's going to be a little tricky, but not so bad. All right, so if I'm graphing this, I'm going to first graph m. M is negative 7, 1 from the origin. So I'm going to go negative 7 to the left, which is about right here, and go up 1. So it's going to be kind of about right there-ish. And that's going to be where that vector is. All right, that's the vector negative 7, 1. We're going to add to that to the head of that vector, this new vector, which is 12 and negative 16. So I'm going to say 12 from this point. I'm going to go 12 to the right, which is going to put me about right here at 5. And then what? Go down, right? Go down 16. So I'm already at 1, so it's going to take me all the way down to negative 15 down here. So I'm going to get another graph that looks like this. This is the other vector right here. Boom. So the resultant vector, which is the sum, we call this a resultant right here, is going to go from where everything started to where it all ended, which is right here. If I look at this vector component from here, I'm going over 5 and down 15, which actually matches the resultant vector. As you can see, this forms a triangle, so they call this the triangle method. But here's vector m, this is vector n, and here's the sum, which is vector m plus n. Okay, so now they want, from that, they want the magnitude and the direction angle of this vector, which is a lot of fun, right? The magnitude is the length of this green vector, and the angle, starting from standard position, is going to be all the way around here. That's what this angle is. It's quite dramatic. So let's find the magnitude first. That'll be pretty straightforward. And we'll say, okay, the magnitude of m plus n, that resultant vector. And we'll take the square root of 5 squared plus negative 15 squared. This will give me the square root of 25 plus 225. So this will be the square root of 250. And that will be the magnitude. And that's how long that green vector right here is. It's the square root of 250, whatever that might be. Okay. What it really is 100 times 20, well, yeah. It's a 10 times 25, so it's 25 times 10. So this is really 5 root 10, if you want to call it that. Technically, that's what the magnitude is, right there. All right. Something else that I have is I have to find the direction angle. This one's a little trickier, but that's okay. Now that I have that magnitude, I can find this answer. I want you to keep in mind something. What I have here is really a right triangle. And there's a reference angle here that I need to figure out. I can call this theta. Now this is the horizontal side of this triangle, so it's an x value, which is a cosine. Okay, so I can actually say that that this number here, 5, okay, 5 is equal to the magnitude, which is 5 root 10, times the cosine of that angle theta. And what I'm really after is the direction angle. So I need to figure out this angle theta, and I can find this direction angle. So I say, okay, I'm going to divide both sides by 5 root 10. These will all cross out. And then I have a cosine theta equals 5 over 5 root 10. So basically now theta, the angle that I want, which is this reference angle, is going to be the cosine inverse of 5 over 5 root 10. And of course you'll need a calculator, and I'll go ahead and mash that in real fast. I'm going to go to trig cosine inverse, and then I'm going to do this, make a fraction, keeps you honest, 5, always put a fraction, 5 over 5 root 10, because that's not true. What do I put the second one? Ugh. 5 root 10. That's what I want. 71.6, we'll say 71.6. All right, so this is 71.6 degrees. That's what this is. If I wanted the whole thing around here, I would just subtract this from 360. And that would tell me the other way of interpreting this angle. So you could actually say this angle is negative 71.6. We can say that's the direction and negative angle right here. So it's going to be a negative 71.6 degrees. That's perfectly fine. Okay, let's do number 15. So that's kind of a long, laborious process there, but these numbers will be a little cleaner, I think, as we go. That one was just kind of tough. And we'll say, okay, number 15. So what I want is the resultant, so I have to add these together. So I want vector A plus vector B, which is negative 4, 3, plus 2, 3. So negative 4 plus 2 is negative 2, and 3 plus 3, which is 6. So we're going to draw this. Draw this, and we'll put some points down. Again, on your test, I'll give you a grid that you can use instead of having to draw this yourself. And then we'll see. So let's graph the first one, which is negative 4, 3. So negative 4, which is over here, and then we're going to go up 3, which is right here. So that's your first vector, negative 4, 3. To that, we're going to add the other vector 2, 3. So I'm going to go over 2, which is right here, over 2 and up 3. So over 2 to the right and up 1, 2, 3. So it's going to put me about right there. And this will give me a resultant vector from here all the way up to here. And that's the answer, which is the same thing as negative 2, 6. So from here I'm going over 2 and up 1, 2, 3, 4, 5, 6. And that's technically what I have here. So that's the resultant vector. The magnitude of that, that's the next quest, right? Find the magnitude or the length of that red vector. So we'll say the magnitude of A plus B is equal to the square root of negative 2 squared plus 6 squared. All right, which is really the square root of 4 plus 36, which is root 40. Root 40. That's the same thing as root 4 times 10, so we'll call this 2 root 10. Is really what it is. And that's the magnitude. That's one of your answers. It's asking you for that. That's the length of the red vector. Now they're going to, of course, ask you for the direction. So we have to figure out my reference angle here, which is this angle. All right. So I'm considering the components negative 2 and the other components, which is up 6. Okay. And I say, okay, that negative 2 is actually when I say negative 2 over the magnitude, which is what? 2 root 10, that'll equal the cosine of theta, when theta is this angle here. So I can then divide both sides. Well, I'll take the cosine inverse of both sides. So I'll tell you that the cosine inverse of negative 2 over 2 root 10 is equal to that angle theta, which I don't know yet. So let's do this in a calculator. The cosine inverse of negative 2 over 2 root 10. So cosine inverse of negative 2 over 2 times root 10. Always wants to jump out of that square root for some reason. And that'll be 108.435. So what I've just found with that calculator is the actual answer, which I wasn't planning on, but it's what it turned out. So what I got is about 108, which is the measure of this angle. 108, what did I say, 0.35? I don't remember. 0.4 degrees. And that's the direction of this vector. So I got your magnitude and got your direction, and we needed some calculator work, obviously, which was what we're going to need for some of these. I think we're down to the last two by the looks of things, so we're almost done with this test or review. So, okay, so let's do this. We do the resultant, so we have to add the vectors. So vector q plus vector r, negative 2, 4, plus 4, negative 3. Negative 2 plus 4 is 2, and 4 minus 3 is 1. So nice, easy one, actually. And then we'll go ahead and draw that really quick with the triangle method. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And let's draw. First vector, negative 2, 4. So I go over 2 and up, 1, 2, 3, 4. Right there. Next vector will be 4, negative 3. So I'll go over from here to the right. 4, 1, 2, 3, 4, and then down 3, which will put me right here. And then I'll get the resultant vector, which is from here to here. As you can see, it's 2 and 1. So I go over 2 to the right and up 1. That's what should have happened, and that's what did happen. Okay, so now we just have to find the magnitude and direction of this vector, and we'll be done with this question. So the magnitude, as I like to write, is now the magnitude of q plus r. And that's the square root of 2 squared plus 1 squared, which is 4 plus 1, so this will be root 5. Okay, that's the magnitude. And the last thing I have to find, of course, is the direction. And the direction is from standard point is this angle here, right here. So I know this distance here is 2, and I know this distance here is 1. So I'm going to say, and I know this length of this green vector is root 5. So that's the hypotenuse, root 5. So I can say definitively, if this were theta, this angle, I could say that the cosine of that theta will be 2 over root 5. So that means that theta will equal the cosine inverse of 2 over root 5, which will give me the answer that I want. So I do trig cosine inverse, control divide, 2 over root 5, and that'll be 26.6 degrees. Okay. And that will be that angle, this angle right here. This will be 26.6 degrees. That's the answer for theta. So that's your direction, that's your magnitude, which is root 5, and then the triangle method is drawn. So the final question, after all that battle, the resultant again, we're going to add a plus b. 4, 3 plus negative 2, negative 4. 4 minus 2 is 2. 3 minus negative 4 is negative 1. Okay, so let's draw this. I'm going to go 4 up 3 over 4 up 3. I'm going to go down 2 and over 4. Down 2 and over 4. Oh, I'm going, that's wrong. So I'm starting from here. I'm actually going to go back 2 and down 4. I'm going to go back 2 and down 4. That's where I'm going. So I'm going to be at -1. So we're going to be right here. Let's go like this. Boom. And then let's give you the final results. Let's change the pen to blue. And that's going to be from here to here. That's the resultant vector, which is 2, -1. So I go over 2 and down 1. And that's what I have, this blue vector. So let's go ahead and find the magnitude and the angle, and then we'll be done with this test review. So the magnitude will be this, will be the square root of this component squared plus this component squared. This will be the square root of 5 again. Okay. That's 2 squared, which is 4, plus 1, which is 5. So this will be root 5. That's the size of this line. That's the length of it. It's the magnitude of the blue vector, which is root 5. I am interested in finding technically either this angle or this angle here, written as a negative. Either one would be okay. I know that this here is 2, right? Because I'm saying that that's 2 in that direction. So if I'm looking for this angle, I can say that 2, and this is the angle here, call it theta. We're going to say then that the cosine of theta will equal 2 over root 5. So I'll do the cosine inverse. Again, we've already found this angle. This will be 26.6 degrees, except it'll be negative because it's going right of the standard positive x-axis. So this is your answer. It's actually it's really the same question. As you can see, the vector that we found here is pretty much the same as the vector we found here, except for the -1. So the angles will be the same as 26.6 and then -20.6. So one of them is going up and this one is going down. Otherwise, it's pretty much the same problem. So those are your answers for all of that. And that's what I'm looking for. This is your direction. This is your magnitude and direction. And then, of course, the triangle method. That's what I'm looking for on those questions. I think that's all of them. So anyway, I hope that was helpful to you. I'm going to wrap up this video now. And watch over this if you are not sure from class. But other than that, I don't think it's going to be that tough for you. And I wish you the best of luck and also a good spring break. So talk to you later. Bye.